This video is about simplifying radicals. So first we're going to practice using perfect squares to simplify radicals. So perfect squares are numbers that multiply to get a number. So when we take the perfect square of that, well, we know that the square root of 25 is 5. In number 2, we have a half out front, but we're still going to focus on our square root first. So the square root of 144 is 12. So we have 1 half times 12, and then 1 half times 12 is 6. In number 3, we have negative square root of 4 plus the square root of 25. So we're going to break down these square roots first. So we have a negative that just comes back out. The square root of 4 is 2. So we have negative 1 times 2. And then we're also going to do the square root of 25, which is 5. So now that we just have numbers without square roots, we're going to do our order of operations. So negative 1 times 2 is negative 2, plus 5 gets us 3. Number 10, or number 4, it's 10 square root 9. Well, the square root of 9 is 3, so we have 10 times 3, which gets us 30. Number 5, the square root of 49 is 7. And in the denominator, we still have 15, so we're going to reduce that fraction to get 1 half. Number 6, there are radicals in both parts of our fraction, so we're just going to reduce our radicals. So the square root of 16 is 4, and the square root of 121 is 11, and we can't reduce that at all. Now, the other square roots that we're going to work with today are not perfect squares. So we're going to have to use factor trees in order to reduce them. When we use a factor tree, we're breaking down a number to its prime factors, which means that they're numbers that only multiply with 1 and itself. So 12, we need two numbers that multiply to 12 to create branches. So two numbers that we know multiply to 12 are 3 and 4. And 4 multiplies by 2 and 2. So now we're at prime factors because I can't break 3, 2, or 2 down anymore. So I'm going to look first and see, do I have any pairs? So I have a pair of 2's. I'm going to cross one of those out because it needs a pair in order to come out of the radical. So because there's a pair of 2's, a 2 gets to go out front now. 3 doesn't have a pair, so it's stuck underneath the radical. We don't use the 4 because we already broke it down into 2 and 2, so if it has a branch coming from it, we're not going to use that number. The square root of negative 45. Anytime that there's a negative under the square root, this is undefined. We can never take the square root of a negative number. And later on, you'll learn about how to turn them into imaginary numbers in Algebra 2. But for now, we're just going to say that a square root of a negative number with the negative sign underneath is undefined. Now, if the negative number is out front, that's okay because it's really negative 1 times the square root of 20. So we're going to break down 20. Two numbers that multiply to 20 are 2 and 10. Two numbers that multiply to 10 are 2 and 5. So we have a pair of 2's and a 5 left over. Now there's already that negative 1, so the negative 1 gets to stay and multiplies with our pair of 2's. Under the radical is the 5 because it didn't have a buddy. So we have negative 2 root 5. So let's practice some more radical simplifying. Number 7, the square root of 60. So two numbers that multiply to 60 are 6 and 10. Two numbers that multiply to 6 are 3 and 2. And two numbers that multiply to 10 are 2 and 5. Now there's multiple ways to break this down, so you could have picked other ways to multiply to 60, but in the end our prime factorization should all end up the same. So I have a pair of 2's, so that's going to go outside the radical as a 2, and underneath the radical I have two numbers left over, a 3 and a 5, so those are going to get multiplied together. So 3 times 5, this gets us 2 root 15. Number 8, the square root of negative 80. Remember when there's a negative number underneath the square root, that is undefined. If you were trying to put that in your calculator, it would give you an error. Number 9, square root of 21. So two numbers that multiply 21 are 3 and 7, and those are both prime numbers. So at this point, I don't have any pairs, which means that the square root of 21 is already simplified. Number 10, negative square root of 220. So two numbers that multiply to 220 are 2 and 110. If you're ever stuck at trying to figure out what numbers multiply and it's an even number, always try 2. Two numbers that multiply to 210 are 2 and 55. Two numbers that multiply to 55 are 5 and 11. So now that I'm at my prime factorization, I have a pair of 2's and a 5 and an 11 left over. Also notice there's that negative. So the negative has to come out front as a -1 times our pair of 2's. Underneath the radical, we have a 5 and an 11 left over. So in this case, we would have -2 root 55. Number 11, the square root of 180. So two numbers that multiply to 180 are 2 and 90. Two numbers that multiply to 90 are 3 and 30. Two numbers that multiply to 30 are 3 and 10. And two numbers that multiply to 10 are 2 and 5. Now, the numbers don't have to be right next to each other for pairs. So I have a pair of 3's in this case, and I have a pair of 2's. So I have two numbers that are going to go out front and multiply with each other. 2 times 3 for the pairs, and we have a 5 left over. So we simplify to 6 root 5. Number 12, the square root of 600. So two numbers that multiply to 600 are 6 and 100. 6 breaks down to 3 and 2. 100 we can break down into 4 and 25. 4 breaks down to 2 and 2. 25 breaks down to 5 and 5. So I have a pair of 5's and a pair of 2's, and then I have a 3 and another 2 left over. So out front are our pairs. So we have 2 times 5. Underneath the radical, we have 3 and 2, which gets us 10 root 6. Now let's try simplifying when there's a number in front of our variable. So if there's a number in front of a variable, we're going to ignore it at first and still break down our radical, and then any pair is going to multiply with that. So when we break down the square root of 18, 18 breaks down to 3 and 6 and 3 and 2. So I have a pair of 2 or a pair of 3's, and I already have that 9 out front. So the 9 out front comes down, 9 times our pair of 3's, and the 2's left over. So we get 27 root 2. 14, we have 2 root 336. So I'm going to break 336 into 2 and 168. I'm going to break 168 into 2 and 84. Now 84 is an easier number to use. So if I know a number that it multiplies with, I know 7 times 12 gets us 84. If not, remember you can keep dividing by 2. 12 breaks down to 4 and 3, and 4 breaks down to 2 and 2. So we have a pair of 2's and another pair of 2's, and we already had a 2 out front. So I'm going to bring the 2 out front times my pair of 2 times my pair of 2. Root, I have a 7 and a 3 left over, so those go under the roots together. So 2 times 2 times 2 is 8. Remember, you're multiplying, not adding them. Square root 21. In the last one, I'm going to break 504 into 2 and 252. I'm going to break this into 2 and 126. And break this into 2 and 63. Now, 63 is a more manageable number to work with. So to multiply to 63, we know it's 7 and 9. And 9 breaks down into 2 3's. So we have a pair of 3's and a pair of 2's. Don't forget there's already a -6 out front. So in this case, we have -6 times a pair of 2's times a pair of 3's. Root, we have a 7 and a 2 left over, so those stay underneath the square root. So -6 times 2 times 3 is -36 root 14.